Welcome everyone to my channel. Question number 31. The ordinate of influence line diagram for bending moment always have the dimension of. Suppose a simply supported beam subjected to a unit load P at the center. The bending moment diagram will be in triangular shape, we know, and the maximum bending moment will be at the center, and the ordinate value will be PL by 4. So Bm maximum equal to PL by 4, and we know this is a unit load P. So if P equal to 1, Bm maximum will be equal to L by 4, and this diagram will be influence line diagram for the bending moment of this beam. So we can clearly say the ordinate of bending moment diagram has a dimension of length of the beam. Option B is right answer. Question number 32. If one end of a prismatic beam AB with fixed ends is given a transverse displacement del without any rotation, then the transverse reaction at A or B due to displacement is, where L is the span of the beam AB and EI is the flexural rigidity. The beam in which the flexural rigidity EI is constant is called prismatic beam. Otherwise, it will be non-prismatic beam. Here in this question, the fixed beam AB, where the support B settles by an amount delta from its original position. There is a transverse displacement of the supports B, but there will be no transverse rotation. So theta will be at here 0 and theta will be at this support will be 0, and the moments and the internal moments will be created by this displacement to make the beam in equilibrium, or to keep the beam in equilibrium. So the two moments at the support A, MA will be equal to 6 EI del by L square, and MB at this end moment will be equal to 6 EI del by L square. We know there is no loading in this beam, so RA plus RB will be equal to 0. The summation of both reaction will be equal to 0. And if we take moment from the point B at this end, so it will be RA into L equal to 2 into this moment, both moments are equal, so RA will be equal to 12 EI del by L cube, that is upward, and RB will be equal to same in magnitude 12 EI del by L cube, but opposite in nature, that is downward. Option D is right answer. Question number 33. If the sinking of a support of a fixed beam causes the beam to rotate in the clockwise direction, then the moments induced at both ends of the beam will be in anti-clockwise direction and of equal magnitude. Option A is right answer. Question number 34. In column analogy method, the area of an analogous column for a fixed beam of span L and flexural rigidity EI is taken as. In column analogy for a fixed beam, the cross section of the analogous column will be length in this direction, and width of this section will be 1 by EI. EI is the flexural rigidity of the beam, so area of this section will be L into 1 by EI, so equal to L by EI. Option A is right answer, L by EI. Question number 35. The degree of static indeterminacy up to which column analogy method can be used is. Column analysis method can be used to analyze the indeterminate structures such as fixed beam, frames, etc. up to 3 degree of static indeterminacy. 3. Option B is right answer. Question number 36. The deflection at any point of a perfect frame can be obtained by applying a unit load at the joint in the direction in which the deflection is required. Option D is right answer. We know this is Castigliano's second theorem. The deflection will be in the direction in which the force is applied. Question number 37. In the slope deflection equation, The deformations are considered to be caused by the bending moments. The slope deflection equation provides the relationship between bending moments, rotation, and deflection. The fundamental principle is that if the moment is applied to a structural element, the structure will deform and resulting in its changes in slope and deflection. Option A is the right answer. Question number 38. The three moment equation is applicable when there is no discontinuity such as hinges within the span. Option C is right answer. This means that there should not be any internal hinges between the successive spans of the beam. Question number 39. While using three moments equation, a fixed end of a continuous beam is replaced by an additional span of zero length. Option A is right answer. Question number 40. Castigliano's second theorem can be used to compute the deflection. In short, I am describing the Castigliano's second theorem. It states that if we make partial derivative of the total strain energy of a structure with respect to the applied force, then we will get the deflection in which or in the direction at which the force is applied, and this theorem can be used to compute deflection for any type of structures. Option B is right answer. Question number 41. Bending moment at any section in a conjugate beam gives in the actual beam the deflection. Option C is right answer. And shear force at any section in a conjugate beam gives in the actual beam the slope. Question number 42. For a two-hinged arch, if one of the supports settle down vertically, then the horizontal thrust remains unchanged. Option C is right answer. If one support settles down vertically, it induces a moment that tends to increase the horizontal thrust, but the arch deforms and counteracts this effect. So equilibrium will come into play and the horizontal thrust will remain unchanged. Question number 43. For a symmetrical two-hinged parabolic arch, if one of the supports settles horizontally, then the horizontal thrust is decreased. Option B is right answer. If one of the support of the arch settles down horizontally, the span of the arch will be reduced, and this reduction of span leads to a decrease in the horizontal thrust. Question number 44. A single rolling load of 8 kN rolls along a girder of 15-meter span. The absolute maximum bending moment will be. Suppose a simply supported girder of length 15 meter is subjected to a single rolling load 8 kN at the center. So maximum bending moment or absolute bending moment under this single rolling load will be at the center, and that will be equal to PL by 4. P is the load and L is the length of the girder. So maximum bending moment or bending moment absolute will be 15 into 8 by 4 equal to 30 kN meter. Option C is right answer. Question number 45. The maximum bending moment due to a train of wheel loads on a simply supported girders always occurs under a wheel load. Option B is right answer. Question number 46. When a uniformly distributed load longer than the span of the girder moves from left to right, the maximum bending moment at midsection of the span occurs when the uniformly distributed load occupies the whole span. Option D is right answer. Look, there are two cases for this moving UDL load over the span of the girder. Case 1, when UDL longer than the span, and case 2, when UDL shorter than the span. Suppose our span is AB and UDL moving from left to right. The length of the UDL is greater than the span of the girder. In this case, if we want to find out the maximum bending moment for this span AB, we will get maximum bending moment at the center. The moving load should cover the whole span of the girder. So in case 1, under this UDL load, when it will cover the whole span, maximum bending moment will be at the center of the span AB of the girder. And in case 2, UDL shorter than the span. Suppose the span of our girder is AB equal to 18 meter, but the length of the UDL, that is 6 meter. Now suppose at this point of the UDL load maximum bending moment occurs. The distance between this point and the support B is 12 meter and the distance between this point and support A is 6 meter. So if we make AC by CB, we will get AC by CB equal to 1 by 2 or AC is to CB equal to 1 is to 2. So to get maximum bending moment at that point, the load position should be such that the section divides the load in the same ratio as it divides the span. To satisfy this condition, we have to make this distance x1 is to x2 equal to 1 is to 2. X1 is the distance between this point and left of this UDL, and x2 is the distance between this point and right of this UDL. In this case, x1 will be 6 into 6 divided by 18 equal to 2 meter, and x2 will be 12 into 6 divided by 18 equal to 4 meter. And if we make the ratio s x1 is to x2, we will get 2 is to 4 equal to 1 is to 2. So x1 is to x2 is equal to the span of the girder AC is to CB. So we can say the maximum bending moment will occur at this point for this case when UDL shorter than the span. Question number 47. When a uniformly distributed load shorter than the span of the girder moves from left to right, then the condition for maximum bending moment at a section is that the load position should be such that the section divides the load in the same ratio as it divides the span. Option D is right answer. Question number 48. When a series of wheel loads crosses a simply supported girder, the maximum bending moment under any given wheel load occurs when the center of span is midway between the center of gravity of the load system and the wheel load under consideration. Option B is the right answer. When a series of wheel loads crosses a beam or girder simply supported ends, the maximum bending moment under any given wheel occurs when its axis and center of gravity of the load system on span are equidistant from the center of the span. Suppose A be our span of the girder, and on the span P1, P2, P3 loads are acting, and R is the resultant of the all the loads. So, and C is the center of the span AB, center of the girder AB. Suppose the resultant load R acts at here at this point, okay, and the maximum bending moment occurs under the wheel P2. So the distance from the point C to the load under which maximum bending moment occurs is same as the distance between this point and the resultant load where resultant acts. So if this distance is x, this distance will also be x. Okay. Question number 49. Which of the following is not the displacement method? Option B is right answer, column analogy method. Question number 50. The Muller-Breslau principle can be used to determine the shape of the influence line, indicate the parts of the structure to be loaded to obtain the maximum effect, and calculate the ordinates of the influence lines. The Muller-Breslau principle can be used for both the determinate and indeterminate beams in order to find the shape of the influence line diagrams. So option D is right answer. All the statements are correct.